students, today's agenda is to check homework. We'll be sketching graphs of polynomials and you will be able to do 3.5. Today, students will be able to create rough graphs for polynomials using zeros. And zeros refers to the solutions for x when a polynomial is equal to 0. But before we start, let's talk about end behavior. When a graph is both even and the leading coefficient is positive, both end behaviors will point up. But when it's even with a negative leading coefficient, then both end behaviors will point down. And ignore this. This was related to multiplicity. That's going to come later in Unit 7. Now, when we're talking about odd, if the exponent or degree is odd, not a pair, not even, and this is positive, then on the left you will see the end behavior pointing down, and on the right it will point up. But if it's odd and you have negative, right, an odd with a negative leading coefficient, then it's going to point up on the left and it's going to point down on the right. One thing that can help you is that when it's odd, if it's positive, it's just like positive slope most of the time. And in here, negative slope most of the time when it's negative. Now let's sketch our graphs using zeros. And to find those zeros, we're going to be doing a combination of what we have learned before, which is factoring. We're going to use synthetic division. In this case, we can check to see if there are two factors that multiply equals -4, but when we subtract them, it's a positive 3, and one pair could be 1 times 4. Because this is positive, that means that the biggest one is positive and this is negative. Let's see if that works. -1 times 4 is -4, and -1 plus 4 is positive 3. So yes, that works. We open our parentheses and then we put x minus 1, x plus 4. And we are now, instead of putting equals to y, we're just going to put equals to 0. It's using zeros, right? The shortcut is just to find the value of x is just the opposite. If we are subtracting 1, we need a positive 1 in here so that 1 minus 1 is 0. Or for this to be a 0, right? Because whenever you multiply a 0 times anything else, the answer is 0. So what would make this factor a 0? Well, if I have positive 4, that means that I need a -4. -4 plus 4 is 0. If you have to show your process, all you have to do is just make this equal to 0, right? X minus 1 equals 0. We cancel by adding 1. And so x equals 0 plus 1 is 1. That's what we get here. The other one is x plus 4 equals 0. If you're adding, the opposite is to subtract. And so x is equals to -4. And so we're ready to graph in here. This is very simple. X is 1, so that's one of my points. X is -4, so I put 1, 2, 3, 4. -4 is right there. And so what that means, because this is positive, that means that my graph will point up. And my vertex, we don't know exactly where it is, but we know that it's a parabola, so it should be symmetrical. So it's going to be in the middle, so somewhere around here, but on Y we don't know how far down it goes. So I shouldn't put a point in there. Don't put a point. Just like that. Okay, it's just a sketch. We don't know this point. For this unit, we're just going to be working with the leading coefficient being a 1. So all I have to do for now is find the factors of our constant in here. So the possible factors are 1. 1 times 6 is 2 factors of 6, and 2 times 3 is another pair of factors for 6. Why do we need this? Because now we have more than just the quadratic equations, and we are going to be using synthetic division to be able to find the first factor. And if I need to, I can continue with synthetic division, but if not, I can see if I'm able to factor after that. So let's try first the positive 1. Okay, positive 1. And for synthetic division that you saw in the previous lesson, remember that we just changed this to the opposite sign. We write the coefficients of these terms, and so it's going to be 1, 6, 11, 6. And the first thing that you do is bring down the 1. After that, we multiply negative 1 times 1 is negative 1. 6 minus 1 is 5. Negative 1 times 5 is negative 5. We add those and we get 6. Negative 1 times 6 is negative 6. And 6 minus 6 is 0. Since we got a 0, that means that, yes, x plus 1 is going to be one of the factors. Okay, so we can say x plus 1 is one of the factors. And what are we going to multiply x times x plus 1? Well, this becomes the coefficient of the next x to whatever degree we have in here. In this case, it's x squared. So 1x squared plus 5x plus 6. Again, just because we got a 0 in here, that means that that's a factor. And for the other factor, these will be the coefficients of the next terms, and constant, of course. How do I decide what to put for this? If this is x cubed, then this is going to be 1x squared, 5x, 6 with no x. Now, because this is a quadratic equation, I can see if I can use the diamond or just directly in here. So we're finding two factors that multiply equals 6, but when you add them equals 5, that will be 2 times 3, 6, 2 plus 3, 5. So yes, we bring down the first factor and just open the two parentheses for our new found factors. And so it's x plus 2, x plus 3. Again, if you have to show your work, you can equal each one of these to 0, but otherwise it's just the opposite basically. For this to be 0, since you have 1, x should be negative 1, or for this one to be 0, since you have positive 2, the x should be negative 2, or if this is positive 3, then x needs to be negative 3, so that negative 3 plus 3 is 0, okay? Those are my three factors, but also, since this is cubed, remember, if this is positive, that means that my graph will shoot something like this, okay? It points down on the left for the end behavior and up on the right for the end behavior. Have that in mind when we graph these points. And so it says that it's going to be at negative 1, negative 2, and negative 3. Negative 1, negative 2, negative 3. Those are my 3 points. So it points down in here. And it will come something like that. Now what you can do also is check on Desmos. If you go on the internet and go to graphing calculator, you go desmos.com, then press the blue button for graphing calculator and just insert the equation. And I was just going to insert it and have it automatically, but I think I want to show you so that you can see even if it's a little slow. So y, then you press equals, x, then you're going to put a to the b power and put 3. Oh, and I'm not showing you the graph, the function in here. Then it's plus 6x squared plus 6x squared. For the square, you can just put a square, and then plus 11x plus 11x plus 6. And you can see in there, those are the points, and you can even press on the points to see where they cross, and you can even see also the y-intercept right there. Okay, again, we're not focusing on those other parts right now, but it gives you an idea of at least the end behavior and where they intercept. And I'll show you the other ones, but I'll just show you the graph. For number 3, I can look at the structure and see that whenever you have the degree 4 and 2, you might be able to just factor and see. Usually when I say this is a perfect square and this is a perfect square, they will be perfect squares. However, I can see that 6 times 6 is 36, but in here we don't have either negative 12 or positive 12. So that wouldn't be an option. The other factors of 36 I can think of is 4 and 9. 4 times 9 is 36. This is negative, so both of them have to be negative because negative times negative makes this positive. So negative 4 times negative 9 is positive 36, but when you add them, negative 4 plus negative 9 is negative 13. So those will be the two factors in here. And so you get x squared. Anytime you see this x to the 4th and x squared, you just put x squared because you're taking the square root of that, and that's x squared. And you put it in both. Then we're going to include this minus 4 minus 9. If you want, you can check to see, just making sure that they are the right factors. Again, the first one is x squared times x squared is x to the 4th. The last term you get by multiplying negative 4 times negative 9 is positive 36. But then the middle term, you just multiply the inside and outside from FOIL, right? So in here, x squared times negative 9, it's going to be negative 9x squared. Negative 4 times x squared is negative 4x squared, sorry. And then in here, that adds to the negative 13x squared. This is just to check. After we do that, we can see that these are now difference of squares. Both of them are difference of squares. And when we have something like that, we can just put equals to 0 now. For each difference of square, remember that we have to open two parentheses, take the square root of both of them, and we put xx to 2. But we don't have a middle term, so that means that one is positive, one is negative. And again, why don't we have the middle term is because 2 times x is 2x, and x times negative 2 is negative 2x, and they cancel. 2x and negative 2x cancel, okay? We're going to do the same thing for the second difference of squares. Again, square root of x squared is xx. Square root of 9 is 3. But again, one positive and one negative. And so, again, for the values of x, if this is positive, then we have negative 2 or positive 2. Remember, it's the opposite. For this one, negative 3 or positive 3. And so the end behavior will be, because this is even, that means that both will point either up or down. Since the leading coefficient is positive, they point up. If it was negative in here, then they would point down. We have negative 2 and positive 2, negative 3 and positive 3. So the graph will go through negative 2, also negative 3, positive 2, and positive 3. Now in here, we don't know where the other points will be, where the y-intercept is, but we know that the graphs will point up, right? And then we can say we're not learning about multiplicity in here, so all of them will just cross the points, then go through the other one, and then something like that. That's okay. We have no idea where the other points will go. I'll show you the graph, and I exaggerated the way they look, but in reality, this is how the graph would look. And if you notice, this should be a lot higher. It's at 36, so that will be way up there. This will shoot up infinitely, okay? So this point right here, again, we don't have to find that, but it's decimals right there. And you can see that mine is not close enough, but again, the focus is on finding those zeros to be able to graph. Okay, for number 4, again, the leading coefficient is 1, and that's why we can just focus on the last term. And what are factors of -3? Well, it can be positive or negative 1 times 3. So we'll just put positive, negative 3. And why positive, negative? Because it can be positive 1 times -3 to make -3, or negative 1 times positive 3 to make the -3. That's why we have to include both of them, okay? And then I recommend that you just start in order. So in here, we're going to put x plus 1. And we just get the -1 in here and start with our synthetic division. We put the coefficients, so 1, 3. Notice how we have x to the 5th, x to the 4th, but we don't have x to the 3rd. We're going to put a 0 in there. X to the 2nd power, another 0. And then x to the 1st power will be -1 and -3. So this is a little bit more interesting. And then we're going to do the same process. For the first one, we just bring it down and then start multiplying. -1 times 1 is -1. And 3 minus 1 is 2. Forgot to mention that this is the opposite sign, okay? And then -1 times 2 is -2. 0 minus 2 is -2. -1 times -2 is positive 2. 0 plus 2 is 2. -1 times 2 is -2. -1 and -2 is -3. -1 times -3 is positive 3, and -3 and positive 3 is 0. Whenever you have 0, that means that this is a factor, okay? So we're going to put x plus 1 as one of the factors, and then again, we're going to put these coefficients and constant with not to the 5th, but the next one. And so it's going to be 1 x to the 4th power plus 2 x to the 3rd power minus 2 x to the 2nd power plus 2 x and minus 3 with no x. We still don't have a quadratic equation, so we continue with synthetic division. And again, we have, for this one, we have positive and -1. And positive and -3. And again, we're going to start with positive 1. You will say, why again with positive 1 if we already got that one? Sometimes you're going to get more multiplicity. Again, we don't, because we're not going to include that in this lesson. But if you get positive 1 and then start with the negative, right? We change the sign. We put the coefficients, and the reason is that if we get 0 again, that means that that's another possible factors, and that will help you for multiplicity. So the coefficients and constant in here is 1, 2, -2, positive 2, and -3. We bring that down. -1 times 1 is -1. 2 minus 1 is 1. -1 times 1 is -1. -2 and -1 is -3. -1 times -3 is positive 3. 2 and 3 is 5. -1 times 5 is -5, and that will give us -8. No, this is not a factor, so we'll go with now -1. Since this one didn't work, I'm going to put now x minus 1, right? The -1 from here. And so again, since it's -1, we put the +1, the opposite in here. I'm just going to copy these right here. So 1, 2, -2, 2, and -3 because we haven't factored anymore. And so, because it didn't work. And so we bring down the 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -2 and 3 is 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. And -3 and +3 is 0. So yay, we found another factor. So again, that means that I'm going to bring down that factor right there, x plus 1. This factor right here, because it worked, x minus 1. And the new remainder, or the rest of the other factor, will be 1. Let me see. 1 instead of x to the 4th. Now we're going to use x instead of x to the 4th. Now we're going to use x to the 3rd. Okay, so 1x to the 3rd plus 3x squared plus 1x plus 3. Again, we still are not down to quadratic, so that we can just factor with diamond or directly, or those perfect special squares. So we still do the +1 minus 1 and plus minus 3. And we know that the +1 is not an option anymore, because we already said that x plus 1 is not possible anymore. So now we got x minus 1, and even though we already got it, we might get it again. Okay, so let's try that one. X minus 1 again. Remember that we changed the sign and we put the coefficients in here. So 1, 3, 1, 3. And so we start by bringing this down. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. 1 plus 4 is 5. 1 times 5 is 5. And 3 plus 5 is 8. So no, this is not 0. This is not a factor once again. It's just one time. So positive 3x plus 3, is that a factor? Let's see. So we put -3 in here. Again, we just copy those because they didn't work. And so you bring down the first one. -3 times 1 is -3. 3 and -3 is 0. -3 times 0 is 0. You get 1. -3 times 1 is -3. And 3 minus 3 is 0. So yes, that's another factor. So I'm going to copy those. X plus 1 that we already got from the first one. X minus 1. And then in here, for this will be the factor. And this will be the other factor. So it's going to be 1. Now it's not x cubed, but x squared. So 1x squared, 0x plus 1. Now we have a quadratic equation. But if you remember from Unit 1, this is a perfect square, and this is a perfect square, but it has an addition. Remember that the special square has to be x squared minus 1, not plus 1. And in Unit 1, we saw that this becomes two imaginary factors. So basically, these will be the only ones crossing the x-intercepts. And these are solutions, imaginary solutions, that do not cross the x-intercept. So we're just going to find that equals to 0 for these 3. X will be equals to, again, if you're adding 1, it will be -1, or -1, that means it's +1. For +3, it's going to be -3. Now, if you were to solve this one, let me just show you. X squared plus 1 equals 0. You subtract 1 from both sides, and then you get x squared equals -1. We take the square root of both, and then x is equals to plus minus. Whenever you have a negative, that becomes an imaginary number. The square root of 1 is 1 imaginary, okay? So again, these do not, they're solutions, but they do not cross the x-axis. Okay, now let's graph this. You have -1 and -3, so -1, -3, and +1. The other thing is that what we started with was x to the 5th is odd, and it's positive, so that means that it's going down on the left and up on the right for the end behavior. So down on the left, so the farther to the left will point down, and then this will point up, okay, something like that. And so we don't know exactly where these cross, right? But we know that there is something like that. Now let me show you on Desmos. You can see that the -3 is right there, -1 is right there, and +1 right there. But then for the other imaginary solutions, you can see that that creates something funny here. That's the y-intercept. That's what we're not looking for that right now. Again, these are the ones that we found in here by using synthetic division. In here is when, once you get to the quadratic, that's when you can use factoring, but in here we can't even use quadratic equation because that gives you imaginary solutions. So again, for this lesson, what we're looking for is that you know where the end behaviors are pointing, and also that you find those zero solutions, okay? We are at the end of this lesson. If you can please give us a thumbs up, subscribe around here. This is the list for the entire unit. This is the next video. Now you're able to do 3.5 and have fun.